I wonder if I can get that away. I'm sure I can. Well, I'm not going to try it. All right, so key thing here. Just like if you were doing 1/2 and 3/4, you can't add those things together until you get the same denominator. The same thing is true when we are dealing with rational expressions with an x and things like that. So first, we must have a common denominator. Okay, so the first example you're going to see, they already do have a common denominator. Once that's true, then you're going to second add or subtract, depending on what symbol we're working with, the numerators and put that over your common denominator. Okay. So, for my first example, I have 5 over a squared plus 3a plus 2 plus 5a plus 1 over a squared plus 3a plus 2. Okay. Do you guys see how on this example these already have the same denominator? So I can go right to my second step then. To simplify that, I would just add my numerators together. I'm just showing you what I'm doing here. Most of you don't need to write this in between step. And you now put it over your common denominator. Okay, could I simplify my numerator at all? Yeah, so after I did this just example, I would skip, if you can see that, I would skip writing this as an in-between step. What adds together? I just wanted you to know, see what I was doing. The 5 and the 1. So this would be equal to 5a plus 6 over a squared plus 3a plus 2. Some of you might ask me, well, do I need to factor the bottom? Sure, it's okay if you factor the bottom. I'm okay with that's fine with me. In this case, there's nothing, I could do 2 and 1 and that would add up to 3. So a plus 1 and a plus 2 would be fine, but that wouldn't cancel the top or anything. So I'm going to just leave it as is. Okay. Good? All right, it's going to get harder. So next, what if I have two fractions that are different and one has an x and one doesn't? So let's say I had something along the lines of 6 over x minus 1 minus 5x over 4. Okay, so first of all, I have a minus here. That's one thing that's a little bit different. And second thing is, do you see how my denominators are not the same? Okay. So in a case like this, all we need to do is we're going to multiply this fraction by the 4 to get a common denominator. And then we're going to 4 over 4. This is how we change to common denominators. And what do you think we're going to multiply this one by? What's the other denominator you see? X minus 1. Okay, so here we go. We're going to multiply top and bottom by x minus 1. Go ahead and put it in parentheses so I remember That's a whole thing. And we're going to multiply the top and bottom of this one by 4. Okay, let's write our new fractions now. And do you see how I have 4 parentheses x minus 1 and 4 parentheses x minus 1? Do you see that common denominator there? Okay, so putting this together, I have 6 times 4, which is 24. Be careful of the subtraction. This is a subtraction. You can think of it as a negative 5x. You're going to distribute it to both things. What's negative 5x times x? It's negative 5x squared, and negative 5 times negative 1 would be a plus 5. And then we're going to go ahead and put it over our common denominator, which is 4 times x minus 1, or you could write it as x minus 1 times 4. Either is fine. Make sure you put a parentheses around your x minus 1. Is there anything we can simplify on this one? The 24 and the 5. 24 plus 5 is 29. So I would simplify the top. It would be negative 5x squared plus 29 over 4 times the quantity x minus 1.
Would that be an answer, or can
Yeah.
you distribute the bottom?
Could you distribute the bottom? Sure, I'm fine with that. That would be totally acceptable. To make, you'd write 4x plus 4, that's fine. Or 4x minus 4. Yeah, when we check answers tomorrow, let's just make sure we're looking at that, like, that sometimes you can it's fine if you distribute. Sometimes it's just not necessary, but it's not wrong, and it's not any less or more simplified, so. Okay, I wanted to do at least one more. What if I had something where I had like a whole number? So let's say I had 7 minus 8 over 4 parentheses 3x minus 2. Okay. So if you see something like this today, we're going to go back to the old concept of you can write a whole number as a fraction by doing what? Putting it over 1. So I'm going to go ahead. What this means really is the denominator there is 1. Okay. So what if we have something like this? Well, we don't have to multiply this by 1 over 1 because it wouldn't change it at all, right? The only thing we would have to do is we'd need to multiply this fraction by the whole thing, 4 parentheses 3x minus 2. So that's what we're going to do. I'm going to squeeze it in right here. I'm going to multiply the top by 4 times 3x minus 2. I'm going to also multiply the bottom by 4 times 3x minus 2. Okay, so on the top now I have, remember this was a subtraction sign. We have 7 times 4 times 3x minus 2. Let's just do the 7 times 4 part. What's 7 times 4? 28 times 3x minus 2 over here. And then I have minus 8. And the common denominator, if you want to distribute, you can, but you can also leave it as 4 times quantity 3x minus 2. There's nothing else I could do on the bottom except you may distribute, okay? But there's not going to be any like terms you can add together. Do you see if you distributed the top, you're going to be able to add the like term with the 8? Okay, let's do that. I need some help here. What's 28 times 3? 84, okay. At 28 times 2? 6, yep. And I still have that minus 8 there, and we can distribute or leave this as 4 parentheses 3x minus 12. All right, the only thing I could do is then I could simplify minus 56 minus 8. And minus 56 minus 8 is minus 64, I believe. Okay. What are we gonna do for homework?